So now let's take this to the next step. Well, if you're using square roots and square roots mean look for pairs, what do you think cube roots mean? Yep, look for triples. So prime factorization again, look what you've got. You've got 8 times 2, then this becomes 2 times 4, bring down the 2, and then look one more time, okay? This is 2 times 2 times 2 times 2, and prime factorization is done. Now you look for triples. Same rule applies as before. You got 3 2's here, take only one representative out. Then you know it's a cube root, and whoever's left behind stays right there. There's your mixed, there's your whole. Watch again. Look at 81. You know and I know that's 9 times 9. Break it down. 3 times 3, that's 3 times 3. So check it out. Look for triplets. There's a triplet right there, right? There's 3. You know it was originally a cubed root. And look what's left. Done. Watch again. This is 625. That might be a little tougher for you to do, but look at this. It ends in 25. So you know and I know one of the factors is probably going to be 25. Bring up the calculator, hit 625, divide it by 25, and see what you get. You get 25. Oh my goodness. This is 25 times 25. Break it down. 5 times 5. This is now 5 times 5. Look for the triplet. There's a triplet. Boom. There's 5. There's the cubed root. There's the cubed root of what's left. Cubed root of 5. Check out how this works. It's really, really quite cool. It's a coincidence that these are all patterns 2 and 2, 3 and 3. Don't look into that at all. 5 and 5. That's a coincidence. That's why we want to do another question. And another question will be right here. Those won't break up nicely. Let's do this one. Square root of 40. Here we go. You know and I know that's 4 times 10. And the square root tells you you're going to look for doubles. Okay, so here we go. There's 2 times 2. 10 breaks down to 2 times 5. There's your prime factorization tree. This tells you to look for doubles. The only double here is this one. So guess what? Take one representative out, put the square root down, take this guy, put it back in. That's going to be 2 times 5. But don't just leave it as 2 times 5 because that's kind of silly, isn't it? Because you know 2 times 5, in fact, is 10. So that's a better way of writing it. Watch again. Let's look at the next question, which is 108. Now 108, again, is not a pretty number. So let's find a number that works into it nicely. How about we try with something like 4? Well, 108 divided by 4 is actually equal to 27. So look how pretty this is. This now becomes 2 times 2. 27, you know, to be 3 times 9. Interesting. Now, most people think they can stop right there. You can't because 9 is not prime. Okay? So here's your 2. Here's your other 2. Here's your 3. But look, there's your other number, which now can break down to 3 times 3. And according to this, again, you're looking for pairs of numbers. So you've got one pair of numbers here, which is 2. You've got another pair of numbers here, which is 3. And the original is square root. And look what's left. Poor little 3 sitting out here by itself. But that's not a nice way to leave it again. You don't just leave something as 2 times 3. 2 times 3 is 6. There's the root, 6 root 3. You are done. Beautiful. That looks a lot nicer. Okay, last question. Here we go. Take a look at this one. This one now says cube root of 32. So you're going to now look for triplets. Right. 32 breaks down really easy. 16 and 2. 16 breaks down to 4 and 4. Each 4 breaks down to, I'm running out of room here, 2 times 2, this one, 2 times 2, and finally the last 2 sits out here. You're looking for a triplet, okay? There's 3 of them right there. Take one guy out. The original is a cubed root of what's left? 2 times 2. Well, wait a second. 2 cubed root of 2 times 2 is just plain old 4. And that's how you make them into pretty mixed radicals.